Now let's start the actual coding part. So I have included some useful libraries like iostream cmath and one namespace using namespace std. And now I will define the function for which you are going to calculate root. So that is double, the return type is double function, and we will take x as argument. And now we will return the value of the function. The function is x cube minus 2 into x minus 2. So now we will define the main function. And here what we will do, we first check whether this is working or not. We will print the hello world and this is indel. Now just compile. There is some that x was not declared, so x will be double type, so type you have to define. And now just check. Yes, it is compiling. So now what we will do, we will declare some variables like a, b, c, epsilon. We will also give the value of a is equal to 1, b is equal to 2. These are the initial cases. Epsilon is equal to 0.0001. This is the tolerance. So why a is equal to 1, b is equal to 2? Because when you put function 1, when you put the value x is equal to 1 inside the function, it will give minus 3, and when you put function 2, it will give some 8 minus 6, that is 2. You can check also here. If you call this value of fun 2, let's say, just compile it, let's see, the result 2 is coming. So the basic criteria of initial guess is the value of the function should be of opposite sign. So this is a is equal to 1, b is equal to 2. You can take any values which are going to give the opposite sign values of the function. Now we will define while loop. So in the while loop, we will give the condition of a absolute b minus a should be greater than epsilon. So if b minus a value is greater than epsilon, then we will inside of the while loop, and if it is less than epsilon, then we will outside of the while loop. So this is what the condition is. Now we again put 3 conditions inside the while loop. If before the condition, just calculate the c, which will be a plus b upon 2, and again we will put the condition if f function value of a function value of c is less than 0, then our interval will be between a and c. Why? Because these are giving opposite signs, that's why the product of these two is negative. So we need to replace b with c. So now new b value is actually c value. So your interval is actually between a and c. So the new b value will be your c value. If it is not true, then one condition would be if function c equal to 0. That means your c is actual root, then nothing to do, it just break the while loop and come outside of the while. And your solution will be your simulation will be your solution will be c. That means c will be your root. You can print the statement here. Root is c. Now the third condition is here you need to define in the form of a string. Now the third condition is else. If these two conditions are not true, then third condition will definitely true, that your interval will lie between b and c. So you have to replace a with your c. You can define one counter also. Int count is equal to so before exiting the while loop, I want to print the counters, that means iterations, how much iterations it required to get the converse solution within that tolerance. So cout iteration number count plus and now we will compile and run our code. See how much iterations is required, 14 iterations, and in addition to that I would like to print the value of a, that means solution, or c. You can put any value a, b, c. You can print any value a, b, c. At the time of the convergence, they will become single values within that tolerance. So I will print the solution at this iteration. Or we can give the value of c And so we are going to print the value of C at every iterations. So let's see. C is 1.5, so you need to give the space so that you can understand. First C is 1.5, and after iteration number 14, the C is 1.6935, which is approximate solution, that is approximate root of your polynomial, which is defined here. The polynomial is x cubed minus 2x minus 2. So for this polynomial, this is the solution. That is 1.76935. You can change the polynomial here, and you can get the root of that particular polynomial with this set of code. So this is the coding in the C++ for the bisection method. Of course, bisection method is quite simple methods, and it requires more number of iteration compared to some advanced methods like Newton-Raphson method, which we are going to cover in the next section. Thank you.